In order to multiply matrices, we first want to check that we can actually do the matrix multiplication. That means we check the dimensions. So this first matrix in example 1 has dimensions 1 by 3, 1 row and 3 columns, and the second matrix has dimensions 3 by 1, 3 rows and 1 column. So in order to multiply the matrices, we need the columns of the first to match the rows of the second, which means these two middle numbers need to match. And then the answer is going to be these two leftover numbers. So it'll be a 1 by 1 matrix. So I'm going to draw a 1 by 1 matrix, but I'm going to leave a lot of room for this spot because we have some work to do. So now to multiply, we take the entries of a row of the first matrix and multiply by the entries of a column of the second. What I mean is we multiply 4 times 0, so the first row spot by the first column spot. And then we're also going to multiply the second row spot by the second column spot, so -2 times 1. And then the third row spot by the third column spot, so 10 times 5. And all of these multiplied entries are going to go in the same spot in the answer matrix, but we also need to add them together. So we're going to add all of these products of the entries of the first row and first column together. So that means that in our matrix, we're going to be adding together 4 times 0, which is 0, plus -2 times 1 is -2, plus 10 times 5 is 50. So this matrix multiplication is equal to the 1 by 1 matrix 48, because we add 0 plus -2 plus 50. So this is the simplest case of multiplication of matrices, where we're just multiplying a row matrix by a column matrix. We end up with a single matrix entry. Now let's do a slightly more complicated example. Example 2, we first check the dimensions. This first matrix is 2 by 2, and the second matrix is also 2 by 2. So we need the middle numbers to match. They do. And the answer is going to be the two leftover numbers, so the answer will be 2 by 2. Now, since matrix multiplication is a combination of multiplying and adding, there's some work to show. So I'm going to write the answer as a 2 by 2 matrix, but I'm going to make the spots in the matrix really large, just so we have some room to do some addition and multiplication. And I like to write an underline for each spot in the matrix. So I've just set up the 2 by 2 answer matrix. And now to do the matrix multiplication, we take rows of the first matrix and we multiply by columns of the second. And we can start with the first row in the first column, which is going to end up going in this first row, first column spot of the answer. So to do this multiplication, we multiply the corresponding entry. So we multiply 1 times 2 in this first spot. And we also multiply -3 times 1. And then we add those two numbers together in the top left. I'm going to go ahead and write that here. 1 times 2 is 2, plus -3 times 1 is -3. And 2 plus -3 is -1, so the top left entry is going to be -1 in this matrix. Now we move on to the first row with the second column. So that would be 1 times 4 for the first entry of each, and -3 times -2. For the second entry. And we add those two multiplications together in the top right spot of the matrix. So that would be 1 times 4 is 4, plus 3 times negative 2 is, or negative 3 times negative 2 is positive 6. So 4 plus 6 gives us 10 in the top right entry of this matrix. And now we move on to the bottom row. And we'll first do the bottom row with the first column. So that would be negative 1 times 2 for the first entries, and 0 times 1 for the second two. And completing those multiplications, in the bottom left spot we get negative 1 times 2 is negative 2, and 0 times 1 is 0. So the bottom left entry of the answer matrix is negative 2. And now the very last column, last row. So this one we do negative 1 times 4 and 0 times negative 2. And we add those two together. Negative 1 times 4 is negative 4, and 0 times negative 2 is 0. So the bottom right entry of the answer matrix is negative 4. So really, we first check the dimensions to make sure that we have the right sizes of matrices to multiply. And then we're taking each row and multiplying it by each column of the second matrix. So with a 2 by 2 by a 2 by 2 matrix, there are 4 spots in the answer to fill up, and each one is filled by taking one of the possible rows with one of the possible columns, and then doing this multiplication and addition with each row and column. One more multiplication example. First, check the dimensions. This first matrix has 2 rows by 3 columns. The second matrix has 3 rows by 1 column. So we check that these middle numbers match, that is, that the columns of the first equals the rows of the second. And then we set up our answer matrix, which in this case is going to be 2 rows by 1 column. So again, I like to set up the answer with kind of a large spot so that we can do our multiplication and addition, but we make sure that we do have the right number of rows and columns in these spots. So we have 2 rows, and then we have just 1 column in this setup. Okay, we take a row of the first row of the first matrix in the first column, which is the only column of the second matrix, and then we multiply and add the corresponding entries. So 5 times negative 2, 0 times 4, and 1 times 3. And then we add all of those together. So this first top spot in the answer matrix is going to be 5 times negative 2, which is negative 10, plus 0 times 4 is 0, plus 1 times 3 is 3. So that spot in the answer is negative 10 plus 0 plus 3, which is negative 7. And now we multiply the other row, the second row, with the first column. And we go piece by piece, negative 1 times negative 2, and 6 times 4, and 2 times 3. That is negative 1 times negative 2 is 2, 6 times 4 is 24, 2 times 3 is 6. So adding all of those entries together, we get 32 for the bottom right entry, or for the bottom entry of this column answer matrix. So one thing to keep in mind as you're multiplying, if we multiply the first row by the first column, that multiplication is going to end up in the first row, first column of the answer. If we multiply the second row by the first column, that's going to end up in the second row and the first column of the answer matrix, which is right here. So that's just how you can learn to place your answers based on the rows and columns that you're starting with in the original matrices.